Welcome. This is the third session, lectures 5 and 6. So we're going to be approaching the halfway mark at the end of this, and then there'll be 3 sessions left. I did want to mention last week I was going through the video and I did notice 2 things. One is I got tongue-tied, and it had to do with the discussion on the Ordovician mass extinction, where there was extensive glaciation. That was 440 million years ago. And it actually lowered the CO2 content in the Earth. And that happens through the orogenies creating the lift, and then you're winding up with huge amounts of erosion, which then sequesters carbon dioxide into the magma. And of course, when the carbon dioxide level goes down, the temperature goes down. I said exactly the opposite. I said when carbon dioxide levels went down, the temperature went up. And you can't have an ice age with the temperature going up. So that was incorrect. And then another place where I that was my right foot in my mouth. The left foot went in on another point when I was talking about at the end of the cryogene, which was between 600 and 700 million years ago. The entire Earth was covered in ice, and the only place where life was able to survive was at the bottom of the trenches where the plates come together because of plate tectonics. So volcanism happened, but the life that lived down there was definitely not phytoplankton. Phytoplankton, thank you, Bill, requires light, and of course there would have been no light. So these were anaerobic plankton-like creatures that were then able to proliferate and then lead to the Ediacaran and the Cambrian explosion of life. So 2 points there I just wanted to clear up. And I think it's, for 4 hours of lecturing, 2 points of incorrectness, I don't think are too bad at all. So just bear with me. Now, what we've been doing, the first 4 lectures,
CBC announced this morning that there's going to be emergency alert put on our phones at 8:05. Okay, I left my phone in the truck.
Oh, okay. Thank you for, okay, so the point was for everybody who's listening in via cyberspace, in about half an hour, give or take, there's going to be lots of weird noises coming out of our cell phones, and it'll last about 10 or 15 seconds. We will pause and then continue. So no coronaries, please. They are surprising when they happen, especially at 2 o'clock in the morning. So the caveat has been, the first 4 lectures were dealing with what I like to term the core sciences. So we're talking about the physics, the mathematics, the statistics, the chemistry, the various components of the atmosphere, how it figures in the science behind the greenhouse effect and runaway greenhouse effect and the climate crisis. That is a pretty objective approach to what's going on. So there isn't too much argument about or interpretation about what's going on in the greenhouse effect. We are now going to start making the transition away from the core sciences. And there was a lot of information, like we talked about the paleontology and the history and birth of the Earth and the atmosphere and the components. Those things are changeable as far as new information comes, but the method of science basically stands apart from what you're looking at. You're not really that involved. As an astronomer looking at a star, you don't affect the star too much. Whereas if you're talking about looking at a culture or an interpretation or psychological perspectives, then a lot of interpretation is required, and you have different schools of thought, and they can be at odds with each other. And so now we're making the shift from the physical sciences, the tangible core sciences, as I term them, to more subjective science. And we're going to start talking about human behavior, and we're going to be talking about mitigation and adaptation. And that's different for everybody. How we would adapt in Canada is different than someone in the Caribbean might be adapting, because there are different effects, different social circumstances, different government systems, different approaches to business, and all of those play in how we deal with the climate crisis. So 2 lectures today. The first one will be about the large-scale mitigation and adaptation from what we know. So the first half of this will be what the science is telling us and how we interpret the climate crisis on us, like where it's coming from, the different categories, that kind of thing. And then it's going to go into the adaptation from a large scale. And this 2 lectures is specifically about big picture stuff. So we're not going to be dealing much with the individual. We're going to be talking big picture, governments, large organizations, industry, banking, finance, categories of people. So I hope that's clear as mud. Any questions? Okay. And if there are, we'll just pause for a second. So here we go. One of the things that we need to talk about, which is related to interpretation, is to do with how the population at large views climate change, the consensus, and the actual scientific consensus. There is a massive disconnect. So if you polled all the sciences, anyone from psychology to anthropology to physics to astronomy to mathematics, the scientific consensus on what's happening in the climate crisis and the veracity of it is almost 100%. It's as close to 100% as you can get. There'll always be outliers and folks who are swimming upstream or for one reason or another. For instance, in quantum mechanics, there's always a physicist who says quantum mechanics doesn't really work, but 99.99999% of the quantum physicists will say, well, it seems to work, and what happened in the photoelectric effect in 1905 is as valid then as it is today. What we're finding is that upwards of 1/3 of the population has absolutely no faith in the veracity of the science of climate change, which flies in the face of what scientists are telling us. The UK is on par with what's happening in the United States, and Canada is slightly above the States. But when we look at the statistics, there isn't much difference between the United States and Canada. And we have a core group of provinces right now that are working very hard to push back against the consensus on climate change, and that would be the prairie provinces. That's Manitoba, Saskatchewan, and Alberta. And of course, there's a great debate going on in Alberta right now in the coverage of the forest fires, why CBC is not labeling this as something related to climate change, which the climate scientists are saying that it is absolutely related. The forest fires and the intensity of the forest fires in northern Alberta is a direct result of the climate crisis. And if there were no climate crisis, the chance of the early intensity and extent of the forest fires would be 1 in 100. So there's 99% certainty that the climate crisis is exacerbating this. But this just gives you a bit of a perspective. This is mostly European. We probably, in many ways in Canada, share more in terms of secularity, the relationship to science as opposed to looking at dogmatic opinion, more with Europe, more with the European Union than we do with the United States. And you can see that in the elections of various governments, although we do have our contingents that do push against it. So that having been said, there is a disconnect, the disconnect between science and public understanding. And so this is what the science says. First, I'm going to talk about carbon dioxide emissions per person globally. And this is a budget that was taken, I believe, in 2016. It doesn't say that on the slide, but Canada, unfortunately, oscillates between second and fourth most intensive, the largest amounts of carbon dioxide emissions per person. So per person, we are huge emitters. And if you look at the larger scale population, Canada has less than 0.5% of the world's population. And we are probably 4 to 5 times per capita emissions of what India is putting out. And in total, all of Canada puts out what all of Africa puts out. Africa has a population of 1 billion people right now, and it's rising rapidly. So the big four are Saudi Arabia, Australia, US, and Canada from a per capita standpoint. And then it takes a step down. Russia's per capita emissions of CO2 is directly related to the oil industry. They're the world's largest producer of natural gas and the second largest producer of oil. And they have a huge surface area. They're almost, I think it's almost 5.8 million square miles, and the population's about 135, 140 million. So per capita, most of their emissions are industrial and related specifically to the extraction of fossil fuels. United States is mostly industry because it is 50% of all industry in the world is tied to the United States. The surprising fact is that in 1945, the United States, at the end of the Second World War, the United States had 50% of the industrial output of the entire world in its companies, which were all based in the United States at that time. And there's been a big criticism of how money has been able to flow to different parts of the world, but the actual percentage of industry in the world that is controlled by the United States has not changed in 75 years, 1 iota. Still 50% of the entire industrial output of the world is related to the United States. So even though the United States per capita emissions comes in a second, third, or fourth, they're actually more than 50% of the entire world's output because of the industry. You can see the large role that China plays, but there are extenuating circumstances with China. Very many, about 50% of the companies in China are US based. You're talking Tesla, you're talking Google, you're talking all these companies that are based in China, but are actually US owned. So out of all the major nations, India has the lowest per capita, and industrialized nations has the lowest per capita emissions per person. I guess per capita is the same thing as per person of CO2. So global emissions. So we looked at emissions by country. Canada's part of the per capita big four emitters of CO2. China is the world's biggest emitter with half of, even though it's the biggest emitter, its actual emissions per person, there's 1.4 billion people in China, is half of what Canada's is. And there are excuses that we make in Canada saying we do have a hostile climate in Canada. But if you look at Canada, we're basically Chile laid out on its side from the Atlantic to the Pacific. So we're pretty close to the United States. It's our industrialization, agriculture, and manufacturing sectors that are contributing to the CO2. So the views from the perspective is that the US, Canada, and Australia make up over 50% of the world's CO2 emissions. So it's our lifestyle, it's our industrial output, and even though our companies are not strictly all home-based, they're all over the world, they're still controlled by the US and to a certain extent by Canada. So the big elephant in the room is capitalism. Capitalism has increased the standard of living by leaps and bounds over every other system. Winston Churchill said that democracy was the worst form of government with the exception of everything else. And in many senses, capitalism is the same. It's the individual. It's being able to set up companies that do manufacturing. It's more efficient than so many other centralist-driven economies. And that would include communism and various types of socialism. But capitalism also doesn't have much of a conscience outside of the money trail. So if it makes money, it's likely to happen. And so we talk about consuming and getting people to consume, planned obsolescence, and following the money trail where this all comes in. So again, you can start seeing that this is kind of a social science perspective that we're looking at. And as much as what I'm saying appears to be rooted in all the different statistics and facts, there's a huge open discussion happening about where this is coming from, why this is coming from, and the role that capitalism is playing in the climate crisis, and how do we solve it from that perspective. What we're trying to do is go back to the old bugaboo of causation versus correlation. So we can talk about CO2 rises, temperature rises, and increase in GDP. And they all seem to have the same trajectory. They're increasing. And again, is it chocolate in Switzerland and Nobel Prize winners? Is it just a correlation, or is there a cause and effect? So we're going to dive a little bit deeper into that. We're going to look at the per capita emissions of CO2. We're going to look at the GDP per capita. The wealthier you are, it appears, the more CO2 you put out, and the world temperature rise. And they appear to be related. The big question is, how much of a relationship? If you trash an economy, does it mean that the CO2 emissions will go down and the global temperature will go down? Is money connected to a CO2 rise and temperature rise? This is an important question. So another way of looking at it is to look at it with a number of graphs. And you can see the per capita GDP in dollars from 1900 to 2020 in the green. And it goes up pretty steadily. It's not an exponential increase, but it's a definite increase. And then you can take a look at the world temperature rise from 1900 to 2018. It's 2018, not 2020. Just stopped short of there. It also looks the same, but because we've got a lot of information, it's kind of a sawtooth. And then we look at the per capita CO2 emissions in tons worldwide from the same period in red. And you can see there's sort of a plateau in 1970, 1980, it stays flat. And that was used by the climate deniers to actually push back against saying that CO2 and world temperature rise were connected, and now it's starting to go up again. What's changed since 1970 and 1980 is that we're starting to institute other forms of energy and other forms of transport, which is having a bit of an effect, but not enough. So which GHG is the culprit? And by GHG, I mean greenhouse gas. What is the one that we really have to worry about? Well, it appears if we're looking at the output, carbon dioxide is almost 75% of the CO2 problem in which we have control. And then there's methane at about 17.5%. And then you've got the nitrous oxides and various fluorine gases. And these are the gases that come out of industrial output. So water vapor doesn't appear here because it doesn't come out of industrial output unless you're burning hydrogen. which we're not doing enough of yet. So the other thing to remember is the nitrous oxides don't convert into carbon dioxide. So if you've got NO2 or N2O nitrous oxide, you will not switch it over to carbon dioxide. But if you have methane, CH4, it'll combine with oxygen to produce a number of CO2 molecules. So methane has a double effect. Carbon dioxide is really stable. It sticks around for a long time. Once you've got it in the atmosphere, it'll probably stick around for any time between 1,000 years and 100,000 years. And we're still trying to work that out. Methane will break down within 10, it'll start to break down within 10 years into CO2 and water vapor, and then stick around as CO2 and water vapor. So the big gas that we're concerned about is CO2 and then methane. Methane is, depending on how you measure it, is between 30 and 90 times the greenhouse gas that CO2 is. So it's horrible. I don't know if anybody saw the Guardian's article on Turkmenistan, but there's a runaway methane leak happening in the Turkmenistan pipelines. The amount of methane, when measured in climate crisis effect, is the same as the entire output of the UK, which is, Canada is about, well, per capita, we're higher than the UK, but we produce about half the amount of the UK does. So Turkmenistan's putting up twice as much CO2 effect just in leaking methane as Canada puts out in total greenhouse gases. So those types of things are really critical. So we're going to start looking at sector breakdowns now, and we're laying the groundwork for what we need to do. So this is big picture groundwork, where we're looking at various sectors and saying, so what sectors can we look at? And then when we start implementing changes, where do we target those changes? And this comes under the heading of, without understanding, you need to understand not only all the science that goes behind it, like the physics and the chemistry and the biology and the history and all that kind of stuff, but you also need to understand the dynamics of humanity. Like, where is this coming from? Who's putting it out there? And how long has this been put out for? So by sector breakdowns, and this is relating what I was saying just at the top of the lecture, which is, can we connect the money to CO2 and to the rise in the global temperatures? And so if we look at fossil fuels, we see that they're by far the biggest culprits in all of this. So you're looking at metric tons per year, billion. This is gigatons again, from 1800 to 2000. And you can see that petroleum, coal, and actually coal use has expanded. The major culprit in coal is from India and from China, and China more than India. So that's why you see that big green uptick. And you can see that petroleum, which basically fuels most of our transportation and the movement of goods, is also increasing, but it's not the same kind of hockey stick increase. Here we go. Okay, we'll just pause for a second while our pockets make noise. Okay, there we go. That was good for me. All that vibration. Okay, okay, so natural gas is also increased because there's been this big push to say, well, natural gas is better than coal, so let's use more natural gas. And of course, that fit into the fossil fuels producers, but it's been going up hugely since the last 50 years. And natural gas, along with coal and petroleum, make up the vast bulk of it. But I don't know if you knew this, a surprising element comes from construction, cement. The production of cement is a major greenhouse gas emitter. And we do have a company in Halifax that has come out with a proprietary research method of producing low carbon cement. And this is something that originated through a partnership. I believe Dalhousie University was involved in this. So we've got some really good research happening here. But cement production is massive. Not only is it stealing all the beach sand in the world, it is also highly intensive in making the constituent parts of cement so that we can create concrete for buildings and roads and all that kind of stuff. And gas flaring is tiny. If you look at our site, the Otter Lake landfill site, they flare off methane rather than letting it release. They burn it, they put it into carbon dioxide and flare it off. And we shouldn't be doing that. That is something that I have always objected to, even as a counselor, that we shouldn't be flaring off methane. We shouldn't be using it. We should actually be storing it for chemical processes. So I did a little bit of a chat about country by country emissions. And it's no surprise for a variety of reasons. Canada is a highly industrialized country. We also have a wealth of natural resources which relate to the industry. And we also have a wealthy population. Generally speaking, we are among the highest GDPs in the world, along with the Scandinavian countries. And our happiness index is high because fossil fuels are bloody convenient. They're easy to get. They're easy to morph. They're easy to carry from place to place. They're relatively non-volatile. And you throw them in the atmosphere and you forget about them. They don't pile up in your backyard. So they're just so convenient. It's so hard to get off them. So we also have a relatively harsh climate, which relates to our use of fossil fuels. So here are all the countries, and the little circles tell us right now, this is a snapshot of those countries that are producing have the highest potential for CO2 emissions. And you can see China is as big as the US and India and Russia and Europe put together now. But China has 1.4 billion people, and they're still twice as efficient per capita as Canada is, even though their emissions are high. And they also didn't contribute to the early industrialization of use of fossil fuels, which led to up until we got to about 400 parts per million, it was mostly Western activity. And again, a lot of the companies in China that account for China's output are Western companies. So if we're building Teslas in China, we have a gigafactory there, the money that supports that, it's an American company. The lithium comes from all over the world that we're mining. We're mining it in South America, Nevada, and in Canada, we're setting up some lithium mines in Northern Ontario and Quebec in hard rock mines, which we'll talk about that as well, which will present some significant problems. Anyway, you can see that Africa and South America are, negligible compared to the rest of the world. If you're poor, if you have a low GDP, you tend not to put out as many CO2 units per capita. And your standard of living, your death rate is higher, quality of life is lower, that kind of thing. So then let's look at power group. Like, if we're saying fossil fuels are really the bad things out there, how does it compare against other things like biofuels, or moving off of coal to hydroelectricity, or moving away from hydroelectricity to wind power? Are these viable options from just purely a greenhouse gas standpoint? We're not going to talk about reliability or maintaining continuous power to the grid, but what we're actually talking about is total GHG output. What is good and what is not good? And if you look at the life cycle CO2 equivalent emissions, if you're burning coal, your total comes out at almost 1,000 if you're talking grams per kilowatt produced. So it's gases, half natural gas. And so you have the fossil fuel industry saying, okay, so we all cut back to gas and it'll be fine. But the problem is that gas deals with methane, and inevitably we have methane leaks in every pipeline. And we had the Turkmenistan problem now, the gas pipelines, Russia actually leaks more methane in natural gas than we produce in Canada. So they lose it. That's how much gas they have because they're such a huge country. And then there's always the push towards biomass, saying, well, you know, we can chop down our forests and mulch them, or take the grass clippings and make gas out of it. And it's, you know, 2 or 3 times as efficient as coal is for biomass, but it's still not a good solution because what does it do? It takes up forests and it takes away the natural CO2 sink that trees are. Trees store CO2 in the wood. You burn wood, you get heat. That's the carbon being released as carbon dioxide with oxygen. So biomass, even though on the surface of it looks 3 or 4 times better than coal, has significant problems. Solar rooftop, this is where we really start to make a difference. So if we have a push, when you fly into Toronto, one of the first things you notice going into Pearson is you see acres and acres of rooftops, especially the big flat industrial rooftops, and virtually none of them have solar panels on there. Now, solar panels are very good. However, you have to manufacture them. And so you need lithium, and you have to be able to, they have a certain lifetime. They don't last. If you have a coal-fired plant, they're designed to last for 70 to 100 years. Well, right now, solar rooftop is guaranteed for about 10 years, and they figured the lifetime to be between 25 and 30 years. Still a good deal, especially compared to it's 20 times better than burning coal, having a solar rooftop. But there's real problems with, you know, they only work when the sun's shining. And then you have to talk about storage, linking with it. And there's convenience, inconvenience, but they're still better. Hydro is wonderful, but it has an ecological effect. You still have to manufacture the plants, lots of cement, and they're usually not close by. This is the problem with hydro. They're usually out in the wilderness. That's why we've got Muskrat Falls and the James Bay project, and they're way out there. And then you have to transmit the power, and you lose power when you transmit it because of just simple physics. So hydro is good. It's almost twice as efficient right now as solar rooftop, and solar rooftop will probably be more efficient than hydro very shortly. Scale efficiencies are, this is from 2014. This is a decade ago. So nuclear, or nuclear, according to George Bush, nuclear power generation, boy, talk about wading into a morass of conversation when you start saying, let's have nuclear power. There are so many issues with it. It is really hard to say that we should be having nuclear power or not. We're talking modular. There are just so many variations on nuclear power. You're looking at liquid thorium reactors. You're looking at modular reactors. Different permutations of fission. And when we're talking nuclear reactors, we're not talking fusion. Fission reactors deal with radioactive material that generates heat to drive turbines. You change the water into steam, it goes through a tube, drives a turbine, which goes through a magnet, a rotating coil, which generates electricity. And it'll last maybe 50 to 100 years, and then you have to replace everything. You get secondary radiation, and then how do you store it? Nobody wants it in their backyard. And now we're starting to find one further thing that I read was that our biosphere extends probably 40 miles down into the crustal plate. So that even drilling down that far, we can find organisms. And the circulation of water is surprisingly deep. I had a chance to go into the solar neutrino detector in the Creighton mine in Sudbury. It's 8,000 feet below the ground. And when you go into the elevator, when it hits the bottom, the elevator is so long, you're talking 1.5 miles of cable, that it takes about 3 or 4 minutes for the elevator to stop bouncing up and down. It's the weirdest feeling. It takes about 120 people in each elevator to go down. And then we walk to, it's a solar neutrino detector, which I'm going to do a little sidebar here. We're counting neutrinos coming out of the sun. And it uses ultra pure water and deuterium to do that. And it was able to detect a specific type of neutrino. Neutrinos are amazing particles. Right now, every given second you have billions of neutrinos going through you, and you would never notice it. So trapping them is really hard. They can go through a light year of lead without being trapped. However, certain isotopes of oxygen in heavy water trap them really well. And they send off a little spark of light, and we're able to do some really interesting physics. David could tell you a lot more about this, Kara, than I can. Her son is a plasma PhD physicist, so he knows all about this stuff. He should be here lecturing this stuff. Anyway, fusion reactors using the power of the sun. We're nowhere close to getting that, but it's not the nuclear reactors that we're talking about here. And then there's wind and offshore power, wave power, that kind of thing. It's rated so low, by the way, and I haven't seen any papers on this, because we're not that concerned with the biosphere on the ocean and its effect on the ocean, because we don't live there for the most part. So it's perhaps a little suspect. I think its CO2 equivalent impact is probably misstated by this graph. So I treat that with a bit of a grain of salt. So by economic sectors, so when you look at big picture, this is what government needs to do. We're talking federal, provincial, municipal. They have to look at greenhouse emissions by economic sector. And so industry is important to us. So what we look at is direct emissions and emissions from electricity and heat. So we need to light them, we need to turn things. It's not only the buildings themselves. So industry is probably 1/3 of everything. Industry generates our lifestyle. It fuels our pensions. It's important to us. It fuels our economic lifeblood, but we need to figure out how to make it more efficient, because a huge part of it, over 20%, is direct emissions in industry. So if we looked at mitigating and adapting industry better, there's a big place for that. Land use. We're not very efficient. We're still plow and till people rather than looking at vertical gardens, greenhouses, different types of agriculture. We're still using agriculture that's 10,000 years old. Brute force method. Haul the water, drop it onto the plants, kill everything else out, grow a monoculture, and eat it. And we've got to learn from that. So land use is a major problem. It's not so much the urbanization of land use, like the sprawl of cities. That comes more into the buildings part. It's more how we use our agriculture. And That goes into meat production and different type of plant production, vegan versus meatitarian, that kind of thing. Buildings, they play a huge role, and we're just starting to learn how much. We like to hang on to our old buildings, but this old building is surprisingly inefficient. It's been around for a long time, and it's giving us a variety of uses, and it's providing us with a space, but it's very inefficient. It uses up a lot of GHGs. Transportation. This is one where we're making probably the biggest media splash. Right now, we're looking at a generational change in transportation, which was brought about almost single-handedly by Tesla. Not to say that I like Elon Musk in any stretch of the imagination, but his company has revolutionized and pushed so many of the other auto companies into the electrification of transport. And when we talk about transport, we're also talking about not only cars, but transportation, ocean going, ships. Among they burn bunker C, which is a horrendous greenhouse gas producer. So moving goods, moving people, transport is key. So in cities, long haul truck drivers, rail, and air traffic as well. And then other energy, direct emissions, they're not categorized, they're smaller, but these are the big four: industry, land use, buildings, and transport. So if you break it down by greenhouse gas emissions, those are the big ones that you want to be looking at. And this is a further breakdown, which gives you a little more in the way of understanding how our lifestyle, manufacturing and construction is pretty much a quarter of all CO2 emissions, greenhouse gas emissions. And this is where concrete comes in. So manufacturing and construction is directly related to concrete, and that's why it's so high. Transport, road transport, residential is only slightly above 10% at 11. So we can get better at residential, and there are many different ways of doing this. In council, we used to talk about vertical integration, increased density, infilling, putting on more efficient energy systems via solar, insulation, houses that lose very little heat, that kind of thing. And it goes down from, let's see here, land use and change, forestry. That coupled with agriculture is almost 20%. And that's the dark green to the lighter green. There's so much more that we are still hewers of wood and drawers of water to a large extent in Canada. We sell our wood. We're mulching. 50% of all the forest is gone in Nova Scotia, and I think 60% in New Brunswick. And if we opened everything up, that would be gone in 10 years. Right now, driving through most of the roads, we have beauty strips. So there's 100 meters or 100 yards of green, and then there's clear cut. And our logging practices are still archaic, and we haven't really progressed much. And it supports a large home industry. Small and medium-sized industry is highly dependent on that. Whether you're producing wood pellets or construction material or any of those things, turning over forest to agriculture and utilizing the trees is an important part of our economy. So our silviculture has to change. Industrial processes, fugitive emissions, and that's not somebody breaking out of a Burnside and running away. Fugitive emissions are basically emissions that sort of get away from us. Old cars can be considered fugitive emissions. Cars that are driven as antiques, they are much less efficient. For instance, the buses in Halifax, they're designed to last 30 years before we get rid of them, the diesel buses. Those are fugitive emissions. We shouldn't be driving them. You know, the diesels that were manufactured 30 years ago that we're still driving around the city had completely different standards from what we have now. We grandfather the rights not to capture those greenhouse gases or take those trucks and buses off the roads. So waste plays a part, industrial processes, we've dealt with the fugitive emissions, residential and commercial, they play a role, but they're not that bad. They're much less than 20%. So, and we're getting much better at it. And part of this, and I'm going to talk about much more of this next week, but part of this circle of emissions has to do with the offloading of government responsibility onto the individual. So when they talk about residential real estate being a problem, that means it's your problem or your problem because you live in that house. So you should be doing something. You should make your house more efficient. You should put solar panels on, blow in insulation, use electricity instead of oil, and it falls on you. The government's not willing to put those rules into place. They offload it to you to make you feel guilty. They don't provide proper transport for you, but they talk about you needing to buy an electric car. And that basically means a lot of industrial process, but once you get the car made, it's far more efficient, but you still have to buy the car. It comes out of your pocket. The government is not going to increase or treat transportation the way we do water, sewer, and electricity, that it's a right to have. Instead, they treat it as a convenience. If you don't like it, go buy an electric car. So these wheels, when we start to look at things and deal with the social sciences, we get a picture of how interpretive this is. It comes down to whose ox is being gored. You know, the government doesn't have to do anything if they can make you feel guilty about your lifestyle. You want to go take a vacation, you got to fly. Well, they're not going to regulate the air industry because they're afraid of industry. They're going to tell you not to fly. They're going to tell you not to do that. Anyway, that's next week. So this particular curve, again, the circle of death, I guess you could call it, again, has to be interpreted. You have to look at what it's actually saying and how it's saying it. So when we look at the projected share of the power capacity out there, the health of our society is directly related to our energy. Without energy, we cannot maintain our lifestyles. We can't heat our homes. We can't produce our goods. We can't import. We can't insulate ourselves against and feed ourselves against the ravages of the entropy of society, which means that everything runs down. So we have to keep putting energy into the system. And so one of the nice things is that we're seeing the previous graph showed solar costing more than wind. But in actual fact, that changed in 2015. And this particular graph, I believe, is 2020. And yeah, it is at 2020. That's the dotted line. So this graph was made in 2020. You can see in the 6 years how solar has progressed. Solar has become sharing as a more power capacity than coal is. But if you look at natural gas and coal, they're still 50% more than any other single power source. So the good ones are hydropower, wind power, and solar power. The bad ones are bioenergy, natural gas, coal. And so this power capacity, generally speaking, we didn't include oil on this because most power stations in Canada are not oil generated, and they come from coal or natural gas. We've switched over, so we generally don't use oil much anymore. So it doesn't show up on this curve. So anyway, you can see that solar is increasing and becoming exponentially more efficient. Oh, wrong way, wrong finger.
Is it all that hydropower is going down?
Hydropower is going down because most of the accessible hydropower has been used. And so they're not building more hydropower plants because we can't find it. Even though Canada has, I think 40% of the world's fresh water, and that includes rivers and lakes, we've tapped most of the hydropower that we can. And so to tap it further north, I mean, there was a plan to build a dam across James Bay. This was way back when, in the 50s or 60s, and they were going to change it into a freshwater lake and use that dam to generate power. But what they discovered is, how do you get the power from James Bay to the heartland of North America? It's not it's a physics problem, and it's not solvable. And it's in part what we're seeing with Muskrat Falls. All kinds of other issues happen. So hydropower has been pretty much maxed out. There's not a whole lot of it available. And if you're looking in the prairies, it's just not available. You've got the Saskatchewan or North Saskatchewan River, maybe a couple of rivers down in the south of Manitoba, related to Lake Winnipeg, Manitoba, Winnipegosis kind of thing. But hydropower just isn't as available. So that's what we're doing, is we're switching. So now we're going to talk about money connections here. So there are two graphs here. The one on the left is that the top 10%, the top earners, take up by far the most amount of, they give us the most emissions as of 2015. If anything, it's gone up since then. And then the right-hand side just puts everything into perspective. Total emissions are huge of the top 1%. Billionaires, and there's, I think, 1,031 billionaires in the world right now, if I'm not mistaken. And they make up 10%. Those 1,000 people make up 10% of the CO2 emissions with their toys. And so you can see that the people who live at the bottom of the social structure, the earning income, if you're making a subsistence living in the Dominican Republic, you're not part of the problem. You haven't been part of the problem. You're not the one generating that. Our culture is, our Western society, our capitalist way of doing things is generating it. So focusing on the middle class, this tells me that focusing on the middle class is something that the wealthy, the very wealthy, the uber wealthy have been able to switch around to make the middle class, which is a diminishing, shrinking class, feel guilty about their lifestyle because they are not the problem per se, not the way that the top less than 1%, the billionaires are. So by far, wealth is a determiner of how much CO2 you put in things and how privileged you are to do that with impunity. So up against the wall billionaires, I guess, is what we say if you want to solve the climate crisis. CO2 emissions per person for different income classes. Again, it doesn't matter where you are. If you're US, EU, India, China, I can see there's a bit of a cutoff on China there. The highest income produce 10%, produce 30% of the CO2. And the poor produce virtually nothing. So income appears to be related, and it doesn't change when you go from totalitarian government to democracy or to populist government. Although India and China are slightly worse than the democracies are. So to Totalitarian plus capitalism, I guess that could be called fascism, seems to be really bad for the climate. So if you look at governments, there isn't a whole lot of difference between democracies and totalitarian and populist governments. We tend to produce CO2 in the same strata when you look at wealth, basically. And richer countries emit more CO2 per person. You had to wait an hour to hear that. You didn't know that. And you can see, the tons of CO2 per person as you look at the developed countries. We're richer and we produce more CO2. This is the process of science, but because it's a social science that we're talking about now, it's human behavior. Money, expenditure, choice, and CO2 is a hard science. Human populations are social sciences. And so there is a fuzziness that goes with the determining of the statistic. You can situate, if you started looking at grounded research, you could do a grounded research study, I would guess, that would contradict this. And grounded research is basically it's a social, Strauss and Levi, I think, came up with it back in the 70s, where you cherry pick all the stuff that relates to what you think needs to go. And then you use sort of a reflexivity where you say, these are my biases, but I trust this study. And if you did that in physics or math or chemistry or biology, that would be called cherry picking. And it does fit into the social sciences as a viable research method. It's kind of postmodernist, but that's just dissing the postmodernists and the social sciences. There appears to be a relationship, and I think it's a strong relationship. By world region, this is where we start to break down responsibility. And we see that Europe, North America, have been responsible historically. So when we went, pre-industrial was about 270 to 280 parts per million of CO2 in the atmosphere. Today, we're at about 420 to 425, depending on what time of year, day or night, we're measuring the CO2. So we've hit as high, I think, as 422 or 423 at Mauna Loa, the observatory in Hawaii that measures CO2. That we get a lot of our statistics from. But we in the West, and when I talk about West, that's North America, Europe, colonialism, have been responsible for probably from 280 to 400, 90% of the emissions. And we continue to be, because of how the industrialization has been shifted over into the developing countries. I often say third world, that's just an incorrect term. This is developing countries as opposed to developed countries. So we developed on the backs of fossil fuels. And that was a very important point to make, in that we had the luxury when Rockefeller started making his billions and billions of dollars. I sound like Carl Sagan now. He made it in oil. Oil was in Pennsylvania. Oil was in Texas. Oil was in the Gulf. It was everywhere. It was in Los Angeles in the La Brea tar pits. And so we built it on the backs of our society. Our society grew on the back of fossil fuels, and that didn't happen to the developing countries. And so right now, we're pointing the finger at China and India saying, you got to straighten out, but per capita, they're 2, 3, 4 times better than we are at handling emissions than we are. And even though we've imported our industry over there, and we're also historically responsible for pushing it from 280 to 400. So that needs to be taken into account. Yes?
Ralph, for a second. Should we be concerned though when we see Asia, 1991 to 2018, the rapid increase? And, relative to the same period of time for Europe and the Americas. So is that an alarm to us that if that trend where we're not going quite as fast and they're zipping up like this. Is that sort of a red flag that maybe we should be concerned about China and be pointing some fingers? Like, I don't know.
Okay, so Kara's asked the question. If you look at this particular graph, you can see that the orange part for East Asia, and that's representing China, is just huge. It's much larger. It's as large as, I would guess, North America and Europe put together since 1991 to 2018. So that almost 30-year period. And Kara is asking whether we should be concerned about this. There are two factors that I would respond to. Number one is that the emissions that we're doing by world region is kind of spurious, because if you look at who's emitting it, when we looked at the other issues, it was industry. And more than half the industry in China is Western industry. So we've just offloaded our industry to China because they don't have environmental concerns. And the second thing is that China had a rapid ramp up of coal-fired plants, and they're ramping up even more. So yes and no is the question, that we should be concerned about it, but we should be looking at the industrial sectors. It's too easy to say, oh, look at bad China pushing out all that CO2. There are reasons that it's pushing out more CO2, and they're tied to us. China didn't contribute to the CO2 back in 1880 or 1920 or 1950. They didn't have an economy to do that. While they were languishing, we put all that carbon dioxide in there, and that's their argument at IPCC, the Intergovernmental Panel on Climate Change, the various COPs. And they talk about that. And they also talk about the fact that it's a lot of Western, you've got Apple, you've got Nike, you've got Tesla, you've got all those companies working there because their environmental concerns aren't as high as they might be in Canada or the US. So, great point, Kara. And then again, this is part of the parsing of social sciences. It is not easy. It depends on whose ox is getting gored and how you skew things. So what we have here now is cumulative CO2 emissions per person by world region. And you can see that North America, we're still way above everybody else. Higher, almost double Europe, Oceania, which includes Australia, the big bad Australia, and then Central Asia, Middle East, and then East Asia, and then you can see the poor developing countries really fare, and it's not countries, it's regions, fare poorly in their development and money and standard of living, but they don't emit much carbon dioxide, so that's good. So one child in the Congo, the Democratic Republic of Congo, produces about 1/60th of the greenhouse impact as one child does here. That's another way of looking at it. So historically, you can see the various types. Land use has been pretty continuous in its fraction. It's always been about 20%, 25%. Coal has increased, mainly because of industry in China. Oil, you can see there's a slight downtick, but it has increased over the decades. Gas, land use and fossil fuels are killing us. That simple. And that's just the big picture. And you've got large corporations. This is a logarithmic scale. I'm going to wrap up this part of the lecture because there's some stuff I want to go through in terms of how we deal with these particular things, because we get the idea that money is tied to GDP, is tied to carbon emissions, and is also tied to the increase in temperature. And you can see that we continue to increase, although the slope is coming down as of 2019. Still not fast enough. And again, another graph showing GDP emissions correlation. I think we can call it a causation. If you got money, you make more CO2. It's just that simple. If you have a wealthy society, you live higher on the hog at the expense of someone else. And there are 8 billion of us. And generally speaking, those with money get to use more than if your income, and this is 2018, is $50,000 or more, well, you tend to also produce much more CO2. And the cost. This is the cost of GHGs to the economy. So when economists start talking about saying it's too expensive to do something, this is how much it costs not to do something, the damage. This is global economic damage caused by each country's greenhouse gas emissions. And it is huge. And this is in trillions of dollars. Lots and lots of damage. United States, China, Russia, India, Brazil, Indonesia, Japan, Venezuela, Germany, Canada. Canada is on this in spite of having less than 0.5%. And the UK, and you can see Canada and UK are tied for economic damage caused by greenhouse gases. Now, part of the reason, and again, this is interpretation, part of the reason that the United States has so much damage, if we talk about storms and wildfires and all the economically linked climate floods, it's because it costs so much money to repair a house in Canada versus repairing a hut in Dominican Republic. So when we start talking about damage, the Western countries, the developed countries, have much higher insurance claims. So my house goes down, not so bad. Somebody else's house goes down, their palace goes down, then it's going to cost a lot. So again, you have to keep that in mind. You're dealing with a social science. And this is going to start dealing with different, and this is the lead up to the next lecture, the different emission pathways that we have available to us. So we're going to start with this graphic and follow it down and take a look at what we can do. So let's take a 10-minute break, breathe deeply, and don't slash your wrists just yet, because there are things we can do. So anyway, we'll be back shortly. So this is where we left off. These are the emission pathways. And if you look at projected warming by 2100, with no policies in place, by 2100, the temperature increase goes off the chart. If we look at Paris continued, we're better. Paris was back in 2015, and we had this soft agreement that was not enforceable. And then Paris increased, we peak at 2030 and then come down, and we get, control over the CO2. The problem is that once we get above 1.5 degrees Celsius emissions, there are tipping points, and the tipping points are scary. And if we get to 2 degrees, there are more tipping points. And if we get to 2.5 to 4 degrees, we don't know what's going to be happening as far as the effects of climate change. And it then becomes very little mitigation, and almost everything is adaptation. You have to adapt to it or die. So this next lecture, here we go. Did I shut it off? Oh, there we go. Okay, that was end of part 1. And now, mitigation. We're going to talk about the big things we must do based on our breakdown of wealth and the connection between money and industry and various sectors, countries, regions of the world, all that kind of stuff. So politics, money, companies, organizations, companies that affect climate in a big way is what we're dealing with right now. What do they have to do? Our governments and multinationals are responsible excuse me, for so much of our life and our lifestyle. That without cars, you can't function. Without water, you can't function. You have to have electricity to function. And so we have to recognize, in order to function at an economic level, you have to have, at this stage, this is no longer 1950, at this stage, the climate supersedes the economy. The argument is that our governments and companies and multinationals have been making that it's too expensive not to do something. And there are alternatives. So mitigation, big picture. With no climate policies in place, which is kind of where we are now. I hate to say that, but we're looking at 4 to 5 degrees increase. I don't want to see that kind of world. And you're looking at, right now, we're roughly at 50 gigatons of carbon into the atmosphere each year. And we're talking global scales, 4, 5, 6 times as much. Current policies will get us to about 3 degrees, 2.5 to 3 degrees. Pledges and targets will still see us above 2.1 degrees. And of course, then anything below. So the no climate policies is where we are pretty much with the big emitters. China is not going to stop building coal-fired plants. They want to be competitive because they have a totalitarian government. It was pointed out to me that India is the world's largest democracy, even though it is a populist government. But then again, we could have said that about the United States. And so populism is kind of a dangerous sword where it can push into almost a fascist milieu. However, was there a question? No, sorry. This is where the social aspects come in the discussion. So how do we have economic growth without climate degradation? Is this possible? Is this in some way, can we make life better? Can we get better and better at what we do, increase our standards of living without mulching everything that we see out there, killing the climate, killing the ecosphere, taking up land, and just becoming humanocentric at the expense of everything else? So low energy versus carbon. Coal's big and bad, oil's big and bad, natural gas is big and bad. And you can see they've been increasing. On the left-hand side, we've got coal, and year by year it's been increasing. And the same thing with oil. We saw it in various other graphs. So global energy consumption is totally dependent at this juncture on fossil fuels. And the big 3 bad ones are coal, oil, and natural gas. And anybody that plays hockey with that says, oh, natural gas is better than oil or coal, or there's clean coal, or there's carbon sequestration, is astroturfing you. The big gains to be made are not building pipelines, not putting $6.5 billion into a pipeline and subsidizing the tar sands. And they are the tar sands, not the oil sands. They have to make the oil out of the tar they pull out. The tar sands are horrendously harmful to us, and they need to be shut down. I don't care what Danielle Smith says, that it's not good for her economy in Alberta. Globally, what we do in Canada is really important to the rest of the world. We don't do anything. We're a leader in not doing anything. And so nuclear power is in many ways, it takes too long to build. A nuclear power plant can take upwards of 20 years to commission, from the time you agree to build it to the time that it turns on to power. We don't have 20 years. So nuclear power, which is there as a viable alternative, in many ways is not an alternative because we can't get them online quickly enough. Can't build modular reactors. We can't build liquid thorium reactors. We can't build all the 3A, 4, and 5th generation reactors that the nuclear industry talks about. I wish we could build them to offset the big bad ones, but it's just not doable at this stage. This is 2023, 6.5 years left before 2030, which is the fall off the cliff year. Hydro, we've used up most of hydro. Anything that can be tapped for water, that's been done for the most part, and there's basic physics involved. And then other is dealing with solar and wind and tidal. And we were just talking about tidal during the break. Someone had questioned, why can't we get the Bay of Fundy going? Well, the Bay of Fundy is like Niagara Falls. When it comes in, it's like Niagara Falls, and it's got rocks the size of houses and cars going through the water that you don't see. So you put a turbine down there, it's going to get demolished. This is what's been happening. That's why it's been failing. It's a chimera at this stage. The Bay of Fundy's got lots of rocks and sand, and that creates a lot of problem. So low carbon energy versus carbon. We got to go with the renewables, and it's going to be inconvenient. Wind power only works when you have a wind. Solar power doesn't work so well during a full moon. It's not lunar power. It only works during sunshine. So we need to look at ways of integrating energy sources with energy storage. And we're going to get to that in a second. So getting off carbon is the big thing. Okay, why are you not behaving? There you go. Share of power capacity. We've seen that graph before. You can see that solar is the big place, wind is going. And the reason I'm putting this back up again is to show that there is a decline in fossil fuels that's happening. But because of the convenience of fossil fuels, there's one component missing. And that component is storage. And how do you store the electricity so that you can use it when you need it? Like when it gets really cold, or after a storm, or when the power lines go out, or when the wind stops blowing. As I said before, solar panels only work in the daytime and usually best at summertime in Canada. So what we're trying to avoid are tipping points by ameliorating this. And this is what governments need to understand. And so here's a Mercator projection. Excuse me, this is the projection. Well, it's not quite a Mercator projection, it's kind of a skewed Mercator projection, which shows all the continents, including the oceans. It focuses on Africa's in the central area. The big tipping points are the Greenland ice sheet collapse, West Antarctic. This is what we're trying to avoid. And you can see them all there. This is for reference. This is why we're doing this stuff. And these tipping points come in, change our climate. So how do we adapt and mitigate to address these things? And it gives you the probabilities over a scale of years when we start noticing these things. And the big ones are the Greenland, West Antarctic ice sheet, the tropical coral reef die-off, and the northern permafrost abrupt thaw. Those are the big things. It's the polar regions which are being affected right now. Those are the things that we have to rein in very quickly. So emissions cuts versus pledges. So we have been, and if I go back, we learned during when Jean Chrétien was fisheries minister, we learned that if we shut down the information, he was fisheries minister for a while under the first Trudeau regime, and he basically shut down most of the research because without research showing what the conditions were, there was no problem. If you don't have research, you can't identify the problem. You got no problem. What are you talking about? And so what we have done, I would say, we've learned from that. What we've done is do the same thing to the climate crisis. We don't measure the stuff. We don't put money into it. We'll talk about it. We don't have information. We don't do anything about it, but we'll pledge to reduce. And it's not a plan. It's just a pledge. It's like the 2015 pledge that we had that we were going to meet the Paris emission standards, and we didn't anywhere. So what's needed right now is to peak by 2025. And where are we now? 2023. A year and a half from now, we have to peak in emissions to meet what is needed according to the IPCC. Annual emissions must be then, once you peak, have to be reduced 45% to what they are today in 2030. And then you need a rapid decline after 2030 to continue on. This is what's needed versus what's pledged. And it's really important on a provincial level, on a municipal level, and a federal level that those politicians who are putting out their climate programs, that you distinguish between what is needed and what is pledged. Because as soon as you say, we pledge to do this, the idea is that we've done what we needed to do. It's going to meet exactly what we need. They don't tell us. The IPCC says we have to do this, so this is what we're going to do. Instead, they come up with a plan. Do you remember the book Unsafe at Any Speed by Ralph Nader? So General Motors' response to the Corvair was to deny everything that Ralph Nader had said and then institute safety standards that he hadn't thought of to make them look like they were concerned about safety. And that way they sort of did an end run. And you'll find the same thing happening, like a permutation of Jean Chrétien's law. If you don't do the study, you have no information, I don't have a problem. It's the same thing with the climate, that if you appear to be doing something, then you're doing something. If you have a plan to do something, even if it's inadequate, it's better than doing nothing. And in actual fact, that's not true, because it takes people off, it takes attention off of what needs to be done. The energy option mitigation, wind and solar. We're experiencing an exponential growth in solar voltaics and decrease in cost. So both the use of and the decrease in cost are exponential. So I think it's every 5 years, the cost of a solar panel goes down by half. And it's now at the point where it's the cheapest thing that you can do. But as we said before, it does not work at certain times. Wind and solar do not work when you don't have wind and don't have sun. So you need storage methods. And some of the storage methods can be liquid, like you can have solar water heating to heat your hot water. And you can have concentrated solar to produce electricity that can go into the grid. But what you need is storage, battery storage, or some sort of they're toying with hydro storage, where they actually create giant water reservoirs that during the time when they have peak, especially in the summertime, where they have peak power, they're producing more power than you're actually able to use. You use the peak power that's over and above what you need to pump water to a higher level, so that when you need the power, it becomes a hydro source. So you pump it into a reservoir, or you pump it into an aquifer. Another thing that's being done is they're actually using compressed gas in old mines. In Sudbury, they're pumping in, they're using excess heat from the mines to run a pump. It's a thermal pump, which is actually pumping gas, the air, into the mines. and it's hard rock mines, so they're not leaking gas, and they're 8,000 feet below sea level or below the ground. And then when you need it, you run the air through a turbine, and it acts like a windmill. So it turns the turbine, you get electricity. Another one is to fractionate through hydrolysis water. You run electric current through water, this grade 9 experiment, and you wind up with hydrogen in one bulb and oxygen in the other bulb. And hydrogen then can be burned to run a power source. So when we have enough solar, we can actually store in many ways all the energy that we need. And those are the technologies that come online. We have a lot of research going on in that. Wind farms are more expensive now than solar. In 2014, 2015 was the turnover point. But they're more reliable than solar, especially in the Maritimes. We get wind all the time, and with people like me talking, there's a lot of hot air around. And especially in the polar regions, when you wind up with systemic systems, we have low pressure systems coming through, you're getting a fair bit in the way of wind. And there are fewer fluctuations with wind. So you might get pauses at certain times of the day because of daytime heating, but generally speaking, most of the wind farms are churning out electricity, and so they're more reliable. Integrating with demand, this is what we talked about, pumped in hydro, lithium battery storage. Right now, with the increase in efficiency in lithium batteries, you don't have to have a high efficiency lithium battery to store power in your house the way you do in a car. If you have and Hyundai has been really good about this, their Ioniq 5 and the sister company, the Kia EV6, have the capacity to push electricity back into your house. So if you're plugged in and the power goes out, your car will run your house. And depending on how much power you need, it can run your house up for up to a week if you're just using it rudimentary levels. If you're looking at heat when it's minus 25, well, maybe you'll get 8 hours or 12 hours. But that is still amazing. And they take car batteries out when they get to about 70 to 80%. At that efficiency, it's no longer worth having in most electric cars, and they're taking them and repurposing them for home use because you get 2 batteries then instead of 1. And they're cheaper and they will work for another 30 years. And so you can have energy storage. And obviously, you don't care about the weight. Nobody cares about how much your gas furnace weighs or your water tank weighs or anything like that. So what do you care if you have a couple of batteries or 4 batteries built onto a house that can power your house for a week with the excess energy that you get, and it'll store it for years. So lithium battery storage is certainly something that we need to look at. And certainly is a viable alternative because of the fluctuations in the oil industry and the fossil fuel industry like to tell us about all the shortcomings of wind and solar power. And we've covered them. So now just throw in a couple of batteries and I think we're self-sufficient. And then you don't have to deal with when Nova Scotia Power decides not to bury its power lines and just leave them out there for whatever the reasons are, even though in the new developments and in all the water developments and road reconstructions, they continue to leave the power lines out above our heads instead of in the ground, even though it would be feasible to put in there. I see battery storage as being a huge plus. And then, of course, we can talk about hydrogen. You can use it to if your batteries are full, then you can use it to create hydrogen. You can sell hydrogen. It becomes a source of income and put it on the grid, and there's hydrogen power. And you can couple it with existing nuclear power plants. Since they're there already, use them. There is one in New Brunswick, but let's not build any more nuclear power plants. We can't afford them. Preserving carbon sinks, this big picture stuff again. We need to reduce deforestation, cut down the trees willy-nilly all over the place. It's a bad idea on two fronts. One is it destroys the ecosphere. Animals need a place to live. The ecosphere needs to provide us with an environment. Edward O. Wilson, who died about 2 years ago, an incredible ecologist and specialist in ants, suggested that 50% of the earth should be set aside and rewilded, that we should live only on 50% of the earth. This is a political solution. We could do that in Nova Scotia. We could say 50% of Nova Scotia will not be developed. And we could live where we are and grow what we need. And this is not individuals speaking. This is government policy. The Stern Review said in 2007 that one of the most cost-effective ways to reduce greenhouse gas emissions is to rewild, is to put the habitat back in place. So proforestation, take abandoned farmland, stop old growth logging. You can't, an old growth tree, a tree that is 100 years old, will store so much more carbon than a sapling that's 10 or 20 years old. It's working full tilt, cleaning the air of carbon. That big trunk that you can't wrap your arms around in the old growth forests, that's carbon. And then when that tree dies, you cover it up. You either char it, so it becomes biochar, and you cover it up, and you have your silviculture people monitor this so that the tree's carbon goes back into the ground, not the atmosphere. And you forest new areas. So carbon sinks are really important. When the fossil fuel industry talks about getting geoengineered carbon sequestration, they forget to mention that Canada has the largest carbon sequestration mechanism in the world. It's called our forests. They take the carbon out of the atmosphere and they put it into the trunks of the trees and into the habitat. And we got to stop cutting them down. Soils. We're still in the plow and till stage of agriculture. And every time we till the soil, we wind up killing a lot of the organisms that create what we need to sequester carbon. And as I talked at the beginning of this session about the Ordovician, when I misspoke about sedimentation, there is a huge sink of carbon in sedimentary soil, rocks, in the sedimentation of anything. So when water runs down and pushes sand to another area, when it's breaking down the calcium carbonate shelf, all of that is sequestering carbon, lowering the CO2. So we need to decrease, decrease soil carbon. Carbonization is plowing and tilling. Decarbonization is using it in different ways. Multiple crops, being more efficient with agricultural methods, no-till agriculture, institute a carbon smart agriculture. More studies need to be done to help people grow better. If you have an agribusiness, you've got a monoculture. If you want to see monocultures at work in Ontario, just drive between London and Windsor, Ontario. It's topsoil and soya and tomatoes and corn. That's it. Nothing else. Mile after mile after mile. 98% of all the forests in Southern Ontario have been logged out. That was all mature, deciduous climax forest in that area. And look at regenerative agriculture, where one crop will help you with another crop and multiple crops. And then, of course, biochar, where you can burn certain types of forests and plow them under to put the carbon in, but that's plus and minus. Again and again, open for discussion. Wetlands. We got lots of wetlands here. One of the things that I see happening at this time of year. The pitcher plants coming into bloom in Blue Mountain Birch Cove. And there's pitcher plants there because there are peat bogs. And peat bogs are anaerobic. If I were to have a stroke or heart attack and drop dead in a peat bog and it covered me up, you could unearth me 5,000 years from now and I wouldn't look any different than I do now. So peat bogs would sequester all the carbon in my body really, really well. And so wetlands sequester carbon. So it's a good idea, not only for people like me, but for anything else that's going to get sequestered. They store and regulate water. Water is important. Fresh water, they clean it. Wetlands store about 45 million tons of carbon globally each year. And this goes hand in hand with ending deforestation and reforestation. Draining wetlands, never a good idea. That used to be the big thing. Create more agricultural land, et cetera, yada, yada, yada. Bad thing. Draining wetland increases methane emissions. There's stored methane in there. That's why they're called peat bogs. That's why we used to take peat and dry it and burn it. My mother used to tell me when she was a little girl, they had a peat bog, and part of her family's job was to go out to the peat bog and cut the peat, and they called it turf, and then you'd let it drain. You'd put it on wooden racks and it would drain for 6 months and then dry for another 6 months, and then they would burn it. And that would release all the methane and carbon dioxide into the atmosphere. I, of course, didn't explain that to her because you don't talk back to my mother. And buildings account for 23% of human CO2 emissions, and that's industry and residential. So new buildings should have passive solar design, active solar design, zero energy building techniques. This is a no-brainer. Like, why we don't have this right now is just beyond me. And it's not up to the individual. So you're going to build a new house and then you're going to spend an extra $100,000 or $500,000 making it energy efficient without government mandates. If the government mandated this, the cost of these things would come down so that we could afford it. So that we could afford these things. Do I sound anti-government here? Heat pumps. For goodness sakes, stop with the oil trucks and the propane and the gas. Get heat pumps. They're 40% more efficient. And even in the coldest, you get air conditioning in the summertime now, which is fabulous. And never used to, when I came to Nova Scotia, Halifax 35 years ago, never needed air conditioning. I just opened a window. Now we're getting heat waves, and we're going to get one this May. Probably in a couple of weeks, we'll be looking at 30-degree temperatures and 30+ degree temperatures. They're already getting it in the Mediterranean. We need green roofs. That could be solar panels, but it could also be roofs that are relatively flat and insulated so that you can grow crops on top of them, especially in urban areas. They're instituting that in parts of Paris, in parts of Berlin, in some of the Nordic countries. They're instituting green roofs. Reduced concrete use. What they're using now is a special type of prefabricated wood. First of all, the wood is not burned. It is taken, processed, and they can build up to 20-story buildings with this new processed wood, eliminating virtually all use of concrete with the exception of the base of the building. So these are easy things to do that could be instituted almost immediately. Transportation, 15% of all emissions worldwide. Increase public transit. Absolute. Public transit should be considered the same way electricity and water and sewer are considered. A necessity of life. That if you do not have adequate transportation, I do not care for the current policy in HRM, which is we have good transit in those areas that have high densities. That's like saying, if you're rich, you're going to get electricity. Or if you're rich, you're going to get sewer. You poor people, you don't get it. It's just the utmost in nonsense to treat it in any other way. Public transit should be there. And we've got to get off the bus route. We have to institute light rail, trams, continuous pickup in areas that would feed you into the main trunks. All of these can be done. Reduce car transport. I don't care if it's electric or whatever it is. Cars are detrimental to our health. In Canada, we're losing 3,500 people per year directly in deaths because of the car. And now with the predisposition for pickup trucks, these behemoths are deadly to pedestrians in cities. So we're not even counting the human cost in misery that car traffic that we become used to, that we can't go anywhere without the car. I can't go shopping. I can't pay my bills. I can't. Somebody has to get in a car to service me, either to bring me something or to go out there and get it. So, and then use hydrogen instead of diesel. Diesel is the worst of everything. It increases deaths through asthma. It increases lung diseases and allergies. It has a detrimental effect all over the place. And it stopped with the diesel already. I'm not opinionated on this, by the way. Shipping, marine, any ship that uses bunker C cannot come into Halifax Harbor. Just legislate it. Use something else. Bunker C is like burning. There are three types of coal. There's lignite, bituminous, and anthracite. And anthracite is almost hard rock. Bituminous is what you get. It makes your hands kind of dirty. And lignite sort of crumbles in your hands. It's almost peat. Well, marine bunker is the equivalent of lignite coal. It's horrible. And it's dirty. And the engine life is dramatically decreased. Use hydrogen electric instead. There should be no diesel in the harbor. There should be no diesel for recreation. We should get off that. Implement wind augmentation. You know, if you plan right, it doesn't matter if it takes 2 weeks or 2 months for a car park to get here. It's all a matter of inventory and planning. So you have different storage units. The just-in-time transportation method was designed by capitalism so they didn't have to store things and they could move their plants offshore. They could move their plants to developing countries that did not have environmental concerns in place. So if you're not worried about just-in-time capitalism, then put them on sailing ships. They worked really well. They could travel around the world in just a matter of a few weeks, and you could augment. They're already starting to play with this, existing shipping. And it's just a matter of political will to do that. Air transport, this is a tough one. Right now, batteries and hydrogen are just not going to work. Jetliner use continues to rise, and by 2050, it'll be 300% higher than it is now. The thing to do is ban short-haul flights. If you can ban short-haul flights and put it into light rail or commuter rail or some other rail, which they've done in Europe, you're saving about 50% of your flying costs. There really is no easy solution just yet. We're looking at hybrid aircraft, electric hydrogen coupled with traditional, but it's more expensive and more research needs to be done. So that one isn't as easy. Agriculture, this is a big one. The food chain. I love 16-ounce steak on the barbecue. I love ribs that are slow cooked. My excuse is that soya doesn't agree with my internal digestive system. But the truth remains that looking at a plant-based diet and looking at alternatives, and it could be lab-grown meat. Our agriculture system is on the threshold. We need to revolutionize it. So much of the production of large agriculture is abhorrent. Abattoirs, the death factories that we have, anything for pigs to cattle to horses to chickens. It's just an anathema to a conscious, conscienced society. So agriculture has a lot of work to do, and we need to start on a political level, motivating and providing the resources that we need for agriculture. And please don't touch my barbecue. My wife said she's a vegan, but there are problems with the traditional agriculture that leads to veganism. In other words, you cut down rainforest to produce palm oil. You reduce habitat. And it's only the rich people that can afford to be vegan. In developing countries, it's mostly multi-diet. And animals eat the refuse that we can't eat, and then we eat the animals for precisely those reasons. We don't eat them as a luxury. They don't eat them as a luxury in developing countries. And we need to include the loss of ecohabitat. Food waste. This is really bad. 30% of all food is garbage. It's not good for you, is that we waste it. Winds up in the landfill. Stop wasting it. We need to supply chain mitigate. Having the freshest little oranges at Christmas time from Morocco is not a necessity. We need to rethink that. If we revolutionize agriculture, we can actually grow tangerines and nectarines and all the other reens. We could grow them locally. And mitigation on farms, adapting to different crop cycles, and we talked about that, setting up new types of farms, funding new types of farms. Industry, by far the largest emitter, we rely on them. And plastic plays a huge role, which comes from the petrochemical industry. We need to fix this ASAP. We need to look at all the problems that are associated with the production of industry, and especially planned obsolescence. I bought a new fridge 5 years ago, and already the inside is all cracked. My mother had a fridge that lasted 45 years. She had a deep freeze that when she left Ontario to come here, she bought it in 1958. She got a half a cow and a freezer. It was a package. And that, I mean, you could put a couple of bodies in there. It was huge. But that freezer lasted 50 years. We're not building stuff like that anymore. We have planned obsolescence. Got to stop that. Methane leakage, cement production, we've got to stop or reduce and introduce hydrogen electrification. If we're looking at metal production, we are already looking at arc furnaces instead of blast furnaces and hydrogen furnaces. Why do we need coked coal? And then methane leakage is a problem. Getting methane from one place to another inevitably involves leaks. Adaptations. Well, we have to look at our financial institutions and who they're financing. RBC is the biggest financer of the oil industry because it makes money. Right now, they're talking about the Emirates major oil company decreased its profits this quarter. They fell to $67 billion. I should be so lucky to have that kind of a fall in profits. They invest in the oil because it's profitable. We got to stop funding that. We've got to stop funding them on all levels, especially in Canada with the tar sands. Defund big oil, coal, and gas. End of story. Tax the banks on non-green investment support. Make it unattractive and increase the taxes. If you choose to tax, if you choose to invest in coal, you're going to pay a tax on it because coal is detrimental. Municipalities. Green urban planning. End of story. Everything has to be looked at through a green. I'm not talking Green Party. I'm talking about green urban planning. That's in the big picture. Urban forestry. We have to have a silviculture department that specializes in the health of our urban forests, urban canopy. We don't fund it. Or the funding is almost negligible, or we piggyback on top of Dow. Reduce sprawl. We've got to do infilling. We've got to do vertical integration. We've got to look at 15-minute communities so that you can walk out and get everything you need within 15 minutes of walking. Public transport's got to change. Can't have diesel. At the very worst, it's got to be electrified buses, and that's even bad. We can do better than that. Reduce car use. That's not popular, especially given the fact that we have created this culture. It's hugely unpopular. Improve walkability. It's great health-wise. Getting out, walking. My excuse is having 3 dogs. They need to be outside for 3 hours a day in the woods. Otherwise, I get fat. Waste reduction. That is really important. Waste, we have so much waste that goes into the landfill at Otter Lake, and we spend so much money. $150 a ton is what it costs us for waste. National plans, end fossil fuel subsidies, strengthen international agreements, strengthen information instruments. There's too much bullshit out there. You can't tell what's true and what's not true. You need to fund more research, and that looks at interdisciplinary research. You don't know where the next thing is coming from. You don't know how it's going to work. You have to fund everything. End unhelpful subsidies, and that's to agriculture, to banking, special rules, oil, that kind of thing. Increase tax incentives for those wishing to take the risk. And history, take that into account. Recognize our historical contribution. We have benefited. I live high on the hog because we were here first. We had the technology and we got the fossil fuels first, and we didn't care. We didn't know. We started to know in the mid-70s when the oil companies told us, and then buried everything. So end the delay on climate action. I'm tired of the yabbits. Yabbit this, yabbit that. Oh my goodness. We've gone over, and there are the various discourses. And next, we're finished. Next week, it's let's get personal. Okay. Sorry, I went over. Oh, is there a question? Sorry for those who online who submitted questions. We've run out of time this week. Yeah, this is my fault. Richard say this. Okay, I will be thrashed violently out back about the head and thorax after this. This won't happen again. I'm sorry I went over. Take care. See you next week.